Assalamu alaikum warahmatullahi wabarakatuh. In this video, I will show you how to build a cooling and heating system for a greenhouse. I will build the system from A to Z, and I will explain how it works while I'm building it. So first of all, we're going to need thermal mass, a temperature sensor, a thermal reference, a physical to simulate converter, and a scope. Okay. Now, let's connect them. And this one here and this one here. Okay. Change the mass to 100 kilograms, and the specific heat of air is 1.0045 e to the power 3. Okay. Now, after that, we'll need a Wheatstone and a differential amplifier. So I'm gonna go ahead to my project and copy them, since the doctor explained how to build them more than once in his videos. So go ahead and copy them, paste them here. Okay, this one's going to be connected here. Now, we chose the resistances of the differential for the Wheatstone bridge to null at 0. We calculated it through this formula right here. We replaced T with 273.15 Kelvin and found out that the resistance equals this much. Okay, and now for the differential amplifier, we needed it to give 5 volts at 20 degrees Celsius. So how did we do that? We just said that we measured the voltage at 20 degrees Celsius with no gain. Then we said this voltage times certain gain equals 5. So 5 divided by this voltage gives us a gain. Okay, then we transformed, or used that gain to figure out the resistance of the differential amplifier. So these two are the same and these two are the same. These are 100. Now we will need to build a comparison system. So it gets greater than, and we need a physical to simulate converter. One over here like this. Okay, here a constant value 5 representing 5 volts. Go ahead and copy these. This one is here. This one is going to be less than K. Now, these will output a boolean in 0 or 1. So we need a data type conversion. We will convert it to a double data type. Okay, now connect this one here, and we will multiply it by a gain of 5. Why? Because the DC motor I'm about to show you will take an input, a 5 volts, for it to work. So we need it to be 5. Now, I'm gonna go ahead and copy the DC motor from my project, and since I don't know how exactly it works, but I looked it up at mathworks.com and copied the exact model they had there, because I figured out I needed a DC motor to turn on my fan, to rotate my fan. So if you want to know any more information about these DC motors, make sure to check mathworks.com. And we need, of course, sorry, not this one. We need a simulant to physical converter. Okie right here. Okay. Now after that, I will place a scope right here. Okay. Now the fan that we're gonna use, it will contain this this is the fan system, a controlled reservoir, a temperature sensor, and of course the fan. Now, let's get back here. First of all, we need the fan. Okie dokie. That's the fan. Then a controlled reservoir. Right here. Control R. No, Control R. Now I'm going to connect the temperature of this controlled reservoir to the temperature of the greenhouse, because it's the same air, of course, and it wouldn't make any sense to have different air temperatures at the same place. So yeah. Now for the pressure, I'm going to have a constant, and its value going to be 101,325, which is the atmospheric pressure. Okay, yeah, of course, I always forget the Simulink to a physical converter. Okay. Now, this is going to be connected here. We need another mechanical rotational reference over here. And now, a temperature pressure sensor. Okay, you know what? Let's just look it up at the Simulink library. There it goes. Make this one here, and absolute reference. Okay, this one here. Okay, now we're gonna need a physical to Simulink converter and a scope. Over here. Go ahead and copy those. Need another over here. Okay, now this is the fan system, or how to turn on the fan for the cooling parts. Now, we need, of course, the actual cooler, you know, to reduce the heat at our greenhouse. So to build that, we'll need a thermal mass, a thermal reference, a temperature sensor, a physical to Simulink converter, a scope, and last but not least, a controlled heat flow rate source. Now the trick is with this block over here. Okay, let's build this one just like this. Let's say quickly. Here. Now, to rotate it this way, what it will actually do is take temperature from this thermal mass, the greenhouse, and carry it to this thermal mass. Now, this thermal mass represents outside. Okay, so I'm gonna take heat and throw it right outside the greenhouse. This is just outside the greenhouse. Okay, now I will need a physical gain. This gain will be 10. Why 10? We figured out while we're doing this project that 50 watts here would be just good. 5 from this one times 10 is 50. Now this is the cooling part. Now for the heating part, it's just the same with one minor change. So I'm gonna go ahead and copy all this stuff. Just a second. Okay. Okay, let's just put it right here. Okay. Now this is going to be connected to the same reservoir because it's the same air. Whether you're cooling it or heating it, it's just the same air. Okay. And this part will need a Simulink to physical converter. Connect this one right here and this one. Okay, just a second. Oops. And yep. Oh no, go ahead. Yep, there you go. Now, what is the minor change, you may ask? Well, the change is with this, the heat pump or the controlled heat flow source. I'm going to rotate it this side. Now, this time, instead of taking heat from the greenhouse, it will take heat from the outside and transform it, or not transform it, just carry it to the thermal mass or the greenhouse thermal mass right here. So it will take heat from this part, this thermal mass, okay, to that thermal mass, the greenhouse thermal mass, and we'll connect the gain just like the previous one. Okay, now one last thing is our stopping criteria. Now the stopping criteria was made to safely and successfully stop the simulation when it reaches 5 volts. Now it works just like this. Let me show you what is here. It contains a stop function, a stop simulation, and a check static range. Let me just copy those and go here, and I will tell you how they work in just a second. Okay, now this check static range says when the voltage, since I connected it to the voltage, as you can see, when the voltage reaches a value between 5.005 and 4.995, it will count as it's 5 volts. Okay, that's like a margin of error. Okay, and when it's like that, it will send the signal to the stop simulation, and the simulation will stop right there. Okay, now let's go ahead and try this function and run. Okay. Okay, now let's check the temperature. That was 300 here, which is around 27 degrees Celsius. It should be decreased to 20, which it did, as you can see here. Let me just do this. From 300 to 293.15, which is exactly 20 degrees Celsius. Okay, now let's check the temperature of the air just outside the greenhouse. You can see it decreased. Now, the current of the DC motor also, you can see that there is a current, so the fan, it did actually rotate. And another proof that the fan rotated is the pressure. Here the pressure should have dropped. As you can see, the pressure dropped. Why? Because the air gained speed. The speed of the air increased, and then the pressure dropped. Okay, the temperature of the air also decreased. It's the same air as the greenhouse, so from 300 to 293.15. Now, this did not work at all, this part, the heating part. As you can see, this temperature is still the same, 300. This current, it's actually times 10 to the power of minus 26, so it's actually 0. And here you can see the pressure stayed the same. Okay, you may see it's like dropping, but I mean, look at the values, 1.01324999, and here 1.01324999, so it's actually the same. Now the temperature here, of course, it'll drop. Why? Because as I said before, it's the same air. Whether you're heating it or cooling it, it's the same air. The temperature will change here and there. Okay, so yeah, that's how you build this project. Now, there's a little bit an extra work I did on my project here, which is a control panel. Now, this control panel makes it easier to control your system from right here without going and clicking on the elements and, you know, changing the properties of anything. Now, let's say the temperature here, let's say it was 12, okay? And it should heat, right? So let's just click the start simulation button. And it'll start the simulation. It's compiling. And that's a callback error. It's something that functions. Okay, it works. Let's go ahead and just try again. There you go. No error. Okay. Now, here is the greenhouse temperature. As you can see, it was like below the 20 degrees Celsius, and it went up to 293.15. Now, the pressure at the cooling fan, okay, it did not work. It stays the same, 101.5 kilopascals. Here, the heater fan pressure, it dropped as the cooling one in the previous example. You can see the heater is on and the cooler is off. The temperatures, as you can see, every temperature meter has its name. What does it represent? This is the thermistor circuit voltage, and this is the motor current for the cooler and the heater. Now, it looks the same, but let's actually get back to the beginning. Let's just type 3 again, press OK. As you can see, the heater fan, the heater motor, sorry, it was working. Okay, so it means that the fan was actually working. And yeah, that's pretty much it. I would just like to point out that this project was made by me, DJ Adel, and Abdelaziz Khaled, and Ashraf Safi. And I hope this video was informative to you. Thank you for watching, and goodbye.